Good day, sir. I'm Carly Cebuano from BCME. For now, I'm going to discuss about how to read and use STEM tables. So, how to read a STEM table? To read a STEM table, it is important that we learn everything about it, such as different symbols, units, and terms used in the table. This will help us understand the function, purpose, or properties of this in the STEM table to help us to read and use it more effectively. And now let's proceed to basic terminology. Symbols P equals to pressure of the steam or water. T equals to saturation point of steam or water. Vf equals to specific volume of saturated water. Vg equals to specific volume of saturated steam. Hf equals specific enthalpy of saturated water. It is energy required to heat water from 0 degrees to 32 degree Fahrenheit to the boiling point. HFG equals to latent heat of evaporation. It is energy required to transform saturated water into dry saturated steam. And Hg equals to specific enthalpy of saturated steam. It is totally energy required to generate steam from water at 0 degrees Celsius to 32 degrees Fahrenheit. Let's proceed to saturation temperature. What is saturation temperature? Saturation temperature, it is a temperature for a corresponding pressure at which liquid boils into its vapor phase. Also, for water, negative 100 degrees Celsius is the saturation temperature at 1 atm pressure. As you can see the graph, the vertical axis is the temperature and the horizontal axis is the volume. For saturation pressure, a pressure at which a given liquid and its vapor can coexist in equilibrium at given temperature. For water, 1 atm is the saturation pressure at temperature of 100 degrees Celsius. So F equals to saturated liquid and the G equals saturated vapor, and AF equals to property A at the state of saturated liquid state. AG equals to property A at the state of saturated vapor state. AFG equals to change in property a white changing phase from saturated liquid to saturated vapor. From the STEM table, we can evaluate the thermodynamics properties like specific, volume, internal energy, enthalpy, and entropy. So STEM table, they are under the superheated STEM table, saturated STEM table, and temperature-based STEM table. First is saturated STEM table. What is saturated STEM table? A saturated STEM tables is a STEM table is an indispensable tool for any engineer working with STEM. It's typically used to determine saturated STEM temperature from STEM pressure or the opposite, pressure from saturated STEM temperature. In addition to pressure and temperature, these tables usually includes other related values such as specific enthalpy H and specific volume V. The data found in a saturated steam table always refers to steam at particular saturation point, also known as the boiling point. This is the point where water and steam can coexist at the same temperature and pressure. Because each flow can be either liquid or gas, at its saturation point, two sets of data are required. Data for saturated liquids, which is typically marked with an F in subscript, and data for saturated gas, which is typically marked using a G in subscript. Next is superheated steam tables. So what is superheated steam tables? Superheated stem tables, it is the values related to superheated stem cannot be obtained through a regular saturated stem table, but rather require the use of superheated stem table. This is because the temperature of superheated stem, unlike saturated stem, can vary considerable for a same pressure. In fact, the number of possible temperature-pressure combination is so great that it would be virtually impossible to gather them all in a single table. As a result, a large number of superheated stem tables use representative pressure temperature values to form a summary table. In temperature-based system table, you can see that temperature, pressure, specific volume, internal energy, enthalpy, and their units is in temperature, degree Celsius, and in pressure, bar, and units of specific volume, meter cube per kilogram, and units of internal energy is kilojoule per kilogram, and the units of enthalpy is kilojoule per kilogram. In temperature-based timetable, you can see the temperature degree. It begins in 10 to 150 or more than. And here are examples of temperature-based timetable. So, question: what is a specific volume of saturated vapor at 40 degrees Celsius? First, we're going to look at the 40 degrees Celsius of temperature, and then look horizontally in the specific volume and find the saturated vapor. After that, look vertically on a specific volume, saturated vapor, and stop with the temperature of 40 degree. So we can get the final answer. So what is the specific volume of saturated vapor at 40 degrees Celsius? So the answer is 19.515 meter cube per kilogram. Second example of temperature-based steam table. So what is the enthalpy of saturated liquid at 130 degrees Celsius? So we're going to find the enthalpy saturated liquid. First, we're going to look the temperature 130 degree Celsius. Second, you're going to look vertically down the enthalpy of saturated liquid and stop and temperature 130, and through that we can get the enthalpy of saturated liquid at 130 degrees. So the final answer is 546.38 kilojoule per kilogram. So let's proceed to pressure-based steam table. So there will be pressure, temperature, specific volume, internal energy, and enthalpy. We have examples of pressure-based steam table. So first, what is the internal energy of saturated liquid at 70 bar pressure? And what is the saturation temperature? So first, look for the pressure 70 bar, and second, look vertically down the internal energy of saturated liquid and stop with the pressure of 70. So we can finally get the final answer of what is the internal energy of saturated liquid at 70 bar pressure and what is the saturation temperature. So the answer is the internal energy of saturated liquid 70 bar is 1258.2 kilojoule per. The saturated temperature at 70 bar is 285.83 degrees Celsius. Next is superheated steam table. Examples of superheated steam table. Questions: determine the specific enthalpy of water at a state of P equals to 0.01 MPa and 500 degrees Celsius. So first, look at the 500 degrees Celsius temperature. Also, in specific enthalpy, look vertically down and you can get the final answer of the specific enthalpy water. The final answer is 3,489.7 kilojoule per kilogram. And that is all. Thank you.